looks like they've started to close the doors and people are mostly in. Okay. Thank you for all for coming to the talk. My name's Wendy Edwards. I've been interested in security for a long time, and a couple of years ago, I became involved in the NASA Data Nauts program, which is a really great program, and we got a lot of exposure to data science. We had to learn a lot about data science, and so I got very interested in how security and data science could fit together. And that's kind of the story of my interest in the two topics. And also the background, Circle City Space Camp. So actually, let's start by talking about what data science is. So data science is a pretty new thing. It combines a whole bunch of different disciplines in an effort to extract meaningful, actionable insights from data. So one of the big challenges of data science is big data, which is like volume, velocity, and variety. You have a lot of data. It may be coming in fast. It may be very heterogeneous. It may be well structured. It may not be. That could be one of the challenges you have to deal with. And then this is just a fairly popular slide explaining all the different disciplines that go into data science. So generally, to achieve meaningful results, you need to have some kind of domain expertise. Like, for example, somebody who's going to do security data science, if they don't know anything about security, probably they won't get very far. And so data engineering is talking about like some of the nitty-gritty of how you manage the data. Like, for example, if you have if you're dealing with big data, are you using something like a Hadoop or something to deal with your data? That would be the data engineering. You have math and science. Statistics is very big, basically in both general data science and when you get into machine learning. I'm sure. Has anybody ever heard a vendor talk about machine learning in one of their products? Just anybody? Yeah. So statistics is a very big part of that. Essentially, a lot of times with security, you're wanting to get a sense of what's normal and what is not normal. And statistics is a much older discipline than the data science, and that's one of the questions that statistics attempts to address. Visualization is a very good way to allow people to just see what kind of data they have. And we're actually going to be looking at some visualizations later in the presentation. And a hacker mindset, I think probably a lot of you have that already. So that's good. So that's essentially you're taking maybe a messy, not very well-defined situation. Maybe you're in uncharted waters. Nobody's ever dealt with exactly that kind of data, and you need to figure out how to deal with it. So that's where the hacker mindset comes in. So let's start with just an introduction to some commonly used data science tools, which actually we're going to use in some of our examples. And so has anybody ever heard of R? Yeah, that's kind of like an open source statistical programming language. I always thought as an alternative to SAS, but they've got an IDE that you can download for free that's pretty nice. It's called RStudio. And they've also got something called Shiny, which is like if you want a web interface for your R code. And R does fairly nice, also has fairly nice mapping and GIS functionality. And then I'm sure probably like, who has not heard of Python? Right. Right. So Python's really been kind of steadily gaining. I mean, like, back in the 90s, like Perl was seemingly everywhere, and Perl is kind of starting to fade, and Python has been growing for years. A nice thing about Python, which is a little bit like Java, is that there are all these libraries out there and all this stuff you get for free that will for pretty much anything you want to do. And so there's a lot of Python libraries for data analysis and like doing stuff like parsing files and examining IP addresses and stuff, and generating visualization. And then these are just a few examples. I'm gonna probably be like tweeting out my slide deck, but it's just if you want the resources. Canopy is a very nice GUI for like scientific Python that works with the Jupyter notebooks. JetBrains PyCharm, you can get a free community edition, and that is if you're not wanting to do like Django on some certain things. That's really very nice. That's what I use. And then I don't know if anybody has seen the Jupyter notebooks. Those are pretty nice. It's kind of a web interface for Python programming that will like render your stuff, your charts and stuff right in line. We've done some work with that with the data nuts. So let's see. So our first example, we're going to use something called AlienVault. And so probably a lot of you have heard of like threat intelligence and IP reputation. Or have you? Okay. So essentially the whole idea of an IP reputation, you generally only get your IP in the reputation database if your reputation is not good. Like, so you're not, there's like an IP reputation database wouldn't say like this IP is really nice and it goes to church every Sunday. It's like if you make it into the database, there is probably something wrong happening from your IP. And so AlienVault is one of the big players. They provide a free, publicly available IP reputation database. That is just an example of like what some of the lines look like. As you can see, basically the IP, you can see the risk and reliability, what exactly they're doing wrong. Like in here, you're seeing scanning hosts, which I think happens all the time. You can also see spam, malware domain, CNC command and control, a number of things. And then you can see the China and the location, and they're going to try to come up with some those are like latitude and longitude, your GIS coordinates. So that is basically just what is in the data set. And here's an example of just what just a detailed information about what AlienVault provides about some of the IP addresses. If you want to expand the details, like in that case, it's basically it's a spamming and malware domain, and it will tell you like stuff like where it is and who owns it and that kind of stuff. So anyhow, returning to our list, we actually have a very long, extensive list. What if we were curious about which countries in this IP reputation database were our frequent flyers? So basically, which ones show up most often? So, and actually, there is some sample code online. I'll provide a link to afterwards that you can download and run that will generate these exact same graphs. But we actually used R to generate it. So basically our frequent flyers, let's see, to everybody's surprise, China is number 1. Okay. Yeah, and then and this is just basically like the top 20. There are, I think there are, outside of that, there are probably more, but they're pretty small. So let's see. Let's just take another look at this overall set of data. So let's see. So the risk essentially means like how risky is it? How much of a problem could this stuff cause your site? And so let's see, how are the risk values distributed? So it's kind of interesting. A lot of them are pretty low risk, and then as you get into higher risk, they kind of taper off. Right. Okay, another thing that AlienVault has is reliability. So reliability means is that AlienVault gets their information from like a bunch of threat intelligence feeds and a bunch of sources, and the reliability is like how much do they trust that threat intelligence. So as you can see, there's a lot of low reliability as well. Okay, so what is the point of all this? So a lot of times when you're in a SOC, you have threat intelligence. Your big question is, what do you really care about? So like in this database, there's over 250,000 entries in this database. Do your SOC analysts want an alert whenever they encounter one of these IPs? Maybe no. So, maybe the risk and reliability values that we just looked at could tell us something about what you should most care about. Like maybe the stuff with the like the highest risk and the highest reliability is perhaps where you might want to generate alerts, where your analysts might want to spend their time. So the thing of it is, we're looking at we could use something called a contingency table, and that shows kind of the distribution of these two variables. Let's show the one we generated. These were generated using R. So we've got a whole lot of low risk, low reliability. So this big dark green rectangle in the bottom, at the bottom, that looks a whole lot of like noise. That looks a lot like stuff that perhaps your SOC analysts don't really want to be bothered with. So okay, so we've got that. What else can we look at? One of the other things we saw in the database was something called type. Like basically, is it a scanning host? Is it a malware site? Is it CNC? Is it a spamming site? So we could actually create something called a three-way table that will show how all this is distributed. So this is our initial attempt at it, and so this, I don't know if you guys can read this or not, but so essentially almost the only discernible colors you can see in this are in the upper left-hand corner, right? Which happens to be scanning hosts. So it's like the scanning hosts in this scanning hosts are like pretty much drowning everything else out with all this noise. So let's go ahead and do it again, and let's get rid of the scanning host. Okay. So in this case, it's unfortunately a little bit hard to see, but you can start seeing some stuff in the higher risk and higher reliability category that's not entirely white. So it's basically like there's some signal in it. And so it's like, basically by doing this, by eliminating the scanning host and eliminating the low risk and low reliability, we got rid of probably almost 95% of the IP addresses. And we were able to weed out a lot of the noise and stuff we don't care about. So that, I guess going back to the discussion, and so the whole goal of using this data science, the data science here was to reduce your false positives, which could generate a lot of noise and waste a lot of analyst time. And in this case, we used visualization because it was easy to see. People are not always going to want to visually eyeball it, and so. Some products will be able to use machine learning to come up with the same conclusions. So let's go on to the next example. So in this AlienVault database, we've got all these IP addresses, right? And so it's like, well, what can IP addresses tell us? And so it's like I think we've all seen at least the IPv4 IP addresses. They're basically consisted of like these 4-bit octets separated by periods, right? As in there's no place like 127.0.0.1. That would be an example of like the IP address represented in this form. So essentially we can use something called CIDR to talk about different IP addresses and to essentially describe the neighborhood. Like the CIDR will describe like a whole range of IP, is a nice way to describe a whole range of IP addresses. And once you get that, you can also get into something called an autonomous system number, which identifies a system, and that's what's used in like BGP routing and stuff. And also, once you know that, some of the sketchier ASNs tend to be connected to each other, and so you can start seeing these neighborhoods of sketchy ASNs. So taking a break, so with the IP address, it's not very hard to find an online service that will geolocate an IP address for you. In fact, you can pass them in as in bulk with some if you want, and then at that point you can generate a map. The one thing about geolocating your IP addresses is that the reliability varies. So I don't know if anybody saw a story with this photo. So this is basically a farm in the middle of like Kansas, in a very rural neighborhood, a very rural area. And so probably several years ago, people in this farm started getting all this hate, and they'd never done anything to bother anybody, but they got all this hate. People even physically dropped stuff off in their driveway. The police came and bothered them. It came and just raided them for no reason. Does anybody know what was going on with that? Yeah. And so basically it was the Max Mind had decided that was the geographical center of the United States. So whenever they had nothing but the country, they had nothing but they geolocated it right on their farm. So anyhow, that is just a warning about the quality of data with geolocation. I would say a lot of times it's right, but sometimes it's not. That said, let's go ahead and generate a map of the AlienVault malicious nodes. And this is just, we're basically taking the coordinates that showed up in the AlienVault database and just making a very simple map using R with them. And you can see so there probably a lot of activity in Europe and the US. So it's another thing called IANA, which is probably the Internet Assigned Numbers Authority, which you've probably heard of. And so it's kind of a hierarchy of if you want to get an IP address, who is in charge of the IP addresses. So IANA is in charge of it, and then you have these other authorities for different geographical areas, and it filters down. So going on, let's actually take a look at some of the IP addresses that showed up at AlienVault by IANA. So you can see IANA. So this is just above. It's just the percentage of like IP addresses allocated to that authority, and below is the number of times they show up in the AlienVault. So you can see that APNIC, which is the Asian Pacific network, is a bit overrepresented. And in fact, that in particular, and so that there's a little bit of uneven representation. So we can also do a graph just by the number of times an IP shows up in AlienVault within a particular IANA domain, and the basically a block count associated to that authority. And you can kind of see the larger IANA domains with more blocks show up more in AlienVault, which is, like, I guess, a pretty common sense conclusion. So our next slide, we're going to talk about the Zeus botnet, which that was some years ago, but I think a lot of people have heard of it. And that was a particularly nasty Trojan. It ran on Windows, and it had a keylogger, and it also installed ransomware. And there's actually an online site that provides data tracking the Zeus. So with the ASNs that we talked about earlier, Cymru provides a very nice IP to ASN mapping service. So essentially, so like the BGP, that's Border Gateway Protocol, and that's basically the kind of routing that's used by the internet, and that contains just some of the information about their internet routing, including who's peering with them. And actually just a number of things that Cymru will give you about a particular IP. So given that, it's a little bit hard to see, but you can actually see the botnet nodes clustered by country, so we're actually using a graph, and the graph kind of shows the relationship, like for example, like one is perhaps peering with another. And you see the U.S. you can see that is unfortunately a bit hard to read, but the U.S. seems to be the most heavily affected. Russia has quite a bit too. And then this actually is not labeled, but basically what they did was they just took the ASNs that they were able to extract from Cymru and just generated a graph and showed the relationship between some of these nodes running Zeus. And so the point of this is really just the connections, like saying that you've got kind of that they're all that's some of the heaviest Zeus activities in like these systems that are closely connected to each other. So this is just another breakdown of it. I'm sorry, is this hard? I'm feeling that this may be hard to read. Okay, great. So this is just breaking it down somewhat by country. So it's also showing the different types, the different types of problems. So it's actually color. So you can kind of see it somewhat with the U.S. that it's color coded to show the Zeus botnets and what specifically you're doing, because Zeus did really kind of quite a lot of bad things. So another area that we can use apply data science and security in is malware analysis. And one area that gets very commonly used is one technique that gets heavily used is graphs, because graphs are very good at showing connections and relationships. And so these are just actually some software that we used. In the links of it, and there's we used GraphViz. I don't know if anybody's used it. It's pretty powerful. And then the PE file. There's really a PE file. A PE file is like a Windows executable, and there's really a number of tools that will analyze PE files for you. This just happens to be a Python module that will do it for you. And then ResTool, that's just a Linux binary that will extract resources from these PE files. Another resource I'd like to point out is VirusTotal. I'm sure probably most of you have heard of that, right? So yeah, so it essentially aggregates a lot of tools online for you, and it will tell you some very interesting things about your file. For example, it will extract interesting strings for you, which can be very useful. Like if you're looking for a maybe a callback domain or something like that. It will extract bundled files. It will run an AV thing to tell you if it already has malware in it that it knows about. And then something relatively new that VirusTotal has added is something called Droidy. And that will analyze Android, that for what it's worth will analyze Android APKs for you. And that will give you a whole lot of information about what it's doing, like what kinds of resources it's having, what kinds of files it's opening, closing, and deleting, and also things like what kinds of permissions it's asking for, which is pretty interesting. But that's just a very nice. I found that to be a very nice resource. So in this case, what we did is we took a bunch of known malware files, and what our code did was it extracted the strings from them, right? Because a lot of times when you've got malware, it's calling back to some kind of host, isn't it, right? And a domain name could be sometimes somewhat better than an IP address because it's like they can just move the, because it's like if they have control of the domain name, they can just move the IP address around if they want, right? So the strings can actually get you back your callback domain. So this is kind of interesting. This is just a number of the strings and potential callback domains that are showing up in these malware files. And what's kind of interesting is you can see on the bottom right hand side, you can see kind of you can see some clusters where multiple suspicious files are calling back to the same host. And that's kind of interesting because that could mean it might come from the same toolkit, it might come from the same author. So it's like if your malware sample is potentially calling the same host, that's potentially worth knowing. And of course, if you look at it, some of these are calling innocuous domains, like if it's like something calling schemas.microsoft.com, you don't really care about that. I mean, that's probably just for rendering or styling or something like that. Okay. So another thing in malware is that a lot of times they include these resources. For example, images. And it's not really very hard. You can use hashing and stuff to tell whether two image files are identical, even if they're not named the same thing. So another thing we took these malware packages and we extracted the resources and we got the images. And we did some graphing to see which ones of them had the same images. So these are images. It's using the icon to show what kind it is. The graph is a bit more extensive, but I figured it would be a little bit, just a part of it would be a little easier to see. So you can see, like for example, multiple suspicious files contain like the same PDF, which is especially interesting because PDFs themselves can contain malware. The PDFs can be malicious. So another thing you might want to look at with malware analysis is possibly shared code analysis. Like, that might allow you to identify, like basically, if you've got like known malware, like particularly like an APT, you can identify something new that might be written by the same authors or with the same toolkits because you see some of the same style is the same. You can look for code similarity, and then you could also generate a graph to visualize how this malware is related. So so how does it work? So you start by extracting features. You can do something called n-grams. N-grams are kind of a statistical tool that kind of represents sequences, or basically if you have a bunch of things happening in a certain sequence. Like for example, the code is making a bunch of the same API calls in the same order. An n-gram would be a good way to tell you that. And then there's also a technique called Jacquard index that will. And so essentially a Jacquard index is. So imagine you're talking about this malware. This malware for you is basically a bag of features, right? And so the Jacquard index is basically, it's pretty much just your area of overlap over your area of union. That's pretty much all it is. So like two malware samples that had a whole bunch of the same features you cared about in common, that would have a very high, that would have a fairly high index. That would probably approach 1. A couple of samples that had almost nothing in common, that would be close. That would be approaching 0, right? And then this is just an example of the graph that it generated, which is not super readable, but it just shows it shows like some potentially very close relationships between these closely related malware incidents, samples, which is somewhat interesting if you're trying to track what it's doing and where it came from. But the point of the graph is just to show the connections and relationships. So actually, I'd like to acknowledge where two books that were really helpful in this. The first one is called Data-Driven Security by Jay Jacobs and Bob Ruders. I posted a link to their site that provides some really good examples to work through, and it also provides some just general ideas about what to do and what not to do. For example, when you're visualizing something. And the second one is Malware Data Science, and that's put out by No Starch Press. In fact, honestly, sometimes if you're really lucky, you can get Malware Data Science as part of a Humble bundle. I think I have. And let's see. Oh, I think I went too fast on that. I think I went too fast on this. So, does anybody have any questions? Yeah.
Based on a lot of these correlations that you're drawing, how in some of these instances, how are you establishing thresholds for those? So that's a really good question. At this point, we don't have a definitive threshold. It's probably trial and error. Like as far as when we're drawing the graph, we're saying it's almost iterative. If you look through some of the example, it's like, well, what we got didn't make much sense. Let's tweak this parameter. And that, to be honest with you, that happens a lot in data science. That it's like it's not quite a matter of like you look up in a book and say, oh, here's this parameter, here's this threshold you got to look at. Yeah.
My wife is getting into information security and appreciates data science. What advice would you have to somebody in that situation who maybe is looking to get into data science and close that contract?
Okay, so there's a lot of free resources and stuff out there on data science. I mean, it's like basically like with InfoSec, there's actually a lot of free and low cost resources available if you look. I mean, you can do the SANS. The SANS has a lot of stuff. There's Cybraces and I played the Holiday Hack Challenge a few times. It was really good. Yeah, but and then you can do kind of low cost stuff like Humble Bundle and stuff. And so a lot of times, for example, if you watch Humble Bundle, there's low cost data science stuff too. The packetpub.com free learning website, which has variable quality, I admit, but they have a lot of free books, and some of those books are related to data science. There's also something like called an online tool that some of the other people in NASA liked called DataCamp. And that's not free, but it's not terribly expensive. And people have thought that was a very good way to learn. And like honestly, the NASA Data Nauts program has been really good. It's gotten a little bit competitive. I think it was less so when I got in, to be honest. But that was a really good resource for me. Yeah.
When you have these visualizations, who are you generally showing them to? Are you showing stock analysts or like I know reading graphs and data, that takes a lot of itself. I imagine you do a lot of education around what they're looking at, and like who's your audience and how you explain what they're seeing graphs and data.
That's a really good question. I mean, at this point, I'm learning too, and so part of my audience is me. So I would actually say probably my audience is people like me who are just learning it, and because being able to see where just being able to see a concept visually, even if it's not pretty or if it's not great to read, is sometimes a lot easier than is really useful as opposed to just reading about it abstractly in text. So at this point, I would say, like for example, some of the graphs I showed. Do I think they would be great for a SOC analyst? No. But I think they are a very good way to like just explain concepts. Like if you want to understand like, well, what is this and how does it work and can I see it? I think that's would be much more be the target audience. Okay. Yeah.
I know you mentioned the data-driven security book.
Yes. Yeah, that was really good.
They did a podcast about the time the book came out. For anybody looking for a resource to talk through some of these issues. So some people, that's easier to hear it.
Yeah. To be very honest, like a lot of the examples here came from the data-driven security, and I also something came from malware from the malware data science, and I put the URL in the slide, and I'll tweet the slide, but those are freely available online. Like anybody who wants to download the data and the code I used, you can do it. In fact, like I would recommend doing it because, like, just getting your hands dirty and struggling and maybe having to tweak something that doesn't work it's a little bit frustrating, but it's a really good educational experience. Yeah.
So you guys went on there. You guys share malware. People would go share stuff. All related to shareware, malware.
Yeah.
So at this point, you take that piece of data, take that big data science, and basically know at this point when I angle IT, so not only could you sit there and point from start seeing where vectors from where like malware is used or what locations appropriately, what networks are used, propagated from, as well as attaching like the known bug factors to get that information on what are the most known attacks and what bombers are really using at a higher rate on the development side, where it should be looked at, where are these holes in the network, what is legacy, what is current, you think that will be the same favorite issues with the whole entire spectrum of cyber where they say they're looking for basically infosec and line up basically network defense, network design, often the option is to go in like many directions. This is what you show.
Yeah,
Donnie, you learned this stuff that you talk about how far.
Actually, yeah. So this was actually the talk on this was pretty basic and low level. To be honest, we didn't even get into machine learning, but there are definitely other projects taking security data science a lot further. One open source project that I've been trying to get involved in is something called Apache Metron, and that is actually using security data and big data and some machine learning. I was going to say, if you want, I could pull it up for you or something, or no? Okay. But basically, there are a lot, and to be honest, like go to a big fair, go to like a big conference or something, and walk through the vendors hall, and you'll see a whole lot of them talking about data and machine learning. And in fact,
But basically, these were kind of toy examples. But dealing with large volumes of data is a known issue. Like Apache Metron is using Hadoop, which is basically a kind of a tool set for dealing with very large sets of data. And then basically Zeek, formerly known as Bro, also has their own way of dealing with very large Bro/Zeek is a network monitoring tool, and basically when you put a tap on a network, on a very busy network, that generates a whole lot of data, and Bro/Zeek has their own specific tools for dealing with a large volume of data. So it's like, so there are a whole lot of people out there already doing very sophisticated stuff. There you go. Yeah, it was. Yeah, it's been a really good program. To be honest, some of the other women, the other people in there are better at machine learning than I am. But I got some exposure to it, and that was kind of cool.
Share with sort of like the basic things they taught you. My background's actually in statistics and economics and mathematics and that sort of thing. We don't use machine learning and stuff like that. So what sort of basic stuff they presented you with initially, if I wanted to go in something like that?
To be honest, I think for me it was even just basic concepts like the idea of supervised versus unsupervised machine learning. Like for example, a supervised machine learning, you have something like what the right, or you have a set of like the right, correct, or desired answers. Unsupervised machine learning, you don't. And there are actually different approaches. There are different more and less complex approaches to deep learning, to machine learning. Like for example, deep learning, which you've heard quite a lot about, I believe is kind of based on neural networks, which are kind of a type of machine learning. Yeah.
You just brought up Apache Metron, which I've never heard of. I just thought it was really cool. So could you give me a use case of how that works or what you would use that for? I'm just asking you because some people might know more now. So is it like a lab, like a dynamic lab?
I believe that it's actually something to help automate some of the job of a SOC rather than to act as a web application. You're talking about web application firewall. I think actually Apache Metron is more to help with a SOC.
Is it logging data or is it trying to prevent stuff?
I'm not okay. So I would see it as more of a intrusion detection system rather than an intrusion prevention system, at least based on what little I know about it. But then again, they keep expanding the functionality, so maybe they will add more to it. Any other questions or? Okay, well, thank you very much for us. Thank you very much for surviving this talk. I figured honestly, if only a few people walked out, I'm going to count it as a victory.